Welcome to Simulacra. I'm Bryson, and this is session 7 of building a decentralized application. In last session, we went through everything Postgres and Superbest databases. So, we set up a database and connected it to Cursor via MCP, Model Context Protocol. We then prompted the agent to build out the database schemas for our user profiles database, and then we set up user authentication and made sure that each user had row level security, meaning that each user can see the changes that they made to their account and only on their account and not system wide. And then we configured Superbase authentication settings and went through the testing and sign up flow and verified that the users were actually in the Superbase dashboard after creating an account on the application. In this session, we're also going to test that users can actually take their crypto address, whether that be from a wallet or an exchange, post it into the application, and retrieve a balance using APIs from the Block Explorer, whether that be a mempool or other Block Explorer based on the blockchain and the token address that the user is trying to receive the balance of. So, I hope you learned a lot from today's video. Remember to like and subscribe. If you have any questions or comments regarding Web3, AI, Bitcoin, or what we go over in today's session, leave a comment in the comment section below. And so, I hope you enjoy, and let's get into it. All right, so over in Cursor, we're going to start a new chat, and we already created a prompt for setting up the user crypto address balance retrieval database. And so we're going to post that prompt into the chat, and then we're going to change to plan mode so that the agent can plan out what it wants to do, and then we'll review the plan and then let the agent build. So the prompt is pretty similar to the first prompt we used to set up the database for the user accounts profile. Instead, we're setting up a database for user address balances table. It's going to have the username, the actual address ID, whether that be from your wallet or an exchange, the address balance, and then the transactional ID. So the address ID is meant to be refreshed every time that the user manually refreshes or reloads the page so that they can have an updated address balance for the address that they posted into the application. Again, we're making sure that the users have row level security so that only the addresses that they're posting on their account they can see on their account, and user system wide don't see addresses from other users. And then also we're telling the agent that we have that environment variable file with the Superbase keys that already exists so that they can use the Superbase MCP to create this database. Okay, so the agent has notified us that it's done setting up the user crypto address balance retrieval database, and now we want to set up the community pool database for when users deploy community pool, they should be able to view all types of information regarding their community pool. And so we're going to paste in the same chat. I wrote up a prompt for this also. And we're going to have some of the same things in the prompt from last prompt. It's going to seem redundant, but you want to make sure that you're telling your LLM repeatedly what to do over and over again so nothing is missed in translation or interpretation. And so again, we're going to have the agent use the Superbase MCP to create a user table so that users can view information regarding their community pools. We gave the agent some of the columns that the user pool database should have, and then we also mentioned row level security and mentioned that the .env file exists again. And so let's put this in plan mode, see what the agent creates as a plan, and then we'll start building and deploying this next database. So now that our agent built both of our databases that we wanted to build, the user pools database and the address balance retrieval database, now we need to check in Superbase to see if our databases were actually created. So we're on the Superbase dashboard. We're on the dashboard for our community pool development page. And so we're going to go over to the left. We can go to table editor, or you can go to database, but we'll go to table editor. And as you can see on the left, you can see the two databases we added, user pools and user address balances. So if we click on user pools, we can see all the columns that we wanted the agent to create: the username, the address ID, the pool balance, the token types that are in the pool, the transaction hash ID, when the pool expires, the the minimum fund, the maximum funding amount, the supported tokens. I think the supported tokens and the token type are probably redundant, so I'll have the agent delete one of those, and then any metadata about the community pool. And if we go to user address balances, as you can see, it also has all of the columns that we wanted the agent to create. So now that we have our main databases created, we want to test to see that a user can actually come to this application, create an account, and then paste a crypto address and retrieve the balance of that crypto address, which will be shown down below. And so to do this, we'll need to set up some RPC nodes using APIs from the different block explorers and mempools so that we're actually getting blockchain real-time data and not just fake data that our application is telling us is there, but it's not actually there. We want to make sure users can actually retrieve a balance from the crypto address they posted. So I think the best way to do this is to use a test MetaMask wallet that I have, put some Sepolia tokens in it. Sepolia tokens are basically just test tokens that don't actually have any value but allow developers to develop using tokens that they can actually send to others, and you can actually see these transactions on the block explorer. We're going to set up a plan for architecting the RPC nodes so that our application can actually talk to these different blockchains. For that, we're going to use Alchemy. Alchemy is a good way to spin up development environments using blockchain nodes to test on testnets, and then it also has a mainnet feature we can switch to once our testing is done and we've made sure that our application retrieves balances like we want to. All right, so this is a very important part of the app. It looks like we have our front end good to go. We know our process and how we want the user to interact with our application. And then we set up the databases on the back end in Superbase as our Postgres databases. And now the most important part is connecting those two ends and making sure that our application actually does what we want it to do. We want to make sure that the users can go to the application here in the address balance community pool info section and post their address and actually get valid information back, such as balances. And so I previously mentioned that we're going to use Alchemy. It's a really good tool in the Web3 community to help us with this task. And so I came over to ChatGPT because I really wanted to get a full functioning prompt together before I went back into Cursor to let my agent start building. And so since I know that I am going to use Alchemy, I wanted to have ChatGPT develop a prompt that was going to take the documentation that I gave it from the Alchemy different web pages and format it into a prompt for this application. And so I just asked ChatGPT, can you develop me a prompt for the Cursor agent to build out the crypto address balance retrieval service for the app? I'm basically telling it that the front end is done, the back end has the Superbase databases, and the database for the user address balances will be called user address balances, and just develop a prompt so that Cursor can build so that users can actually paste an address and receive the balance for that address. And then I made sure to go through all of the Alchemy documentation on connecting to RPC nodes and APIs using Alchemy, getting tokens from a wallet, how to get transaction history for an address on Ethereum, the token API quick start, and pretty much all of the documentation that has to do with this process. I pasted all of the documentation into ChatGPT here, and then I also gave it an overview of the different topics down here. So let's see what ChatGPT generates, and then we will review and then go over to Cursor to start building. Okay, so ChatGPT responded with a very extensive prompt for me to put into Cursor. I've reviewed it and I like everything that ChatGPT suggested. I think I'm probably going to put this into Cursor in chunks so that the agent doesn't get overloaded. When you're working with agents or LLMs in general, you want to make sure that you approach it with an iterative approach. You don't want to give the agent too much context because that is a huge bottleneck. And I think actually this prompt might be just long enough that we're not going to run into context issues. So I'm going to copy this prompt into Cursor. And then I'm also going to give my agent and Cursor access to the documentation in the pages above from Alchemy so that the agent knows exactly how to build out the process of fetching a crypto address, retrieving the balance, and then returning it to the application and then storing it in our database. So now that we're back in Cursor, we're in a new agent chat. We're going to paste the documentation from Alchemy into the agent so that it can reference the documentation. So let's go to @docs in the chat. You're going to go to docs or @docs, and then I'll press add a new doc. And then just going to paste the URL of the documentation that we want the agent to reference. So let's go through each one. And I'm going to actually name the doc based on what doc it is, because I assume that I'm going to have to come back and reference these documents again. And so I want to be able to just say @Alchemy get started, and this document will pop up when I want to reference it. So let's confirm this, and then let's do the documents for the rest of the pages. All right, so we just got done adding all of the documents from Alchemy, and then we also added our prompt from ChatGPT. We're in plan mode, so we're going to have the agent review this prompt. We have this prompt broken up into 2 phases, so we just have the first phase first, which is just to inspect, plan, and then propose the architecture. We'll have this agent plan, we'll build, and then we'll go into the next phase 2, which is the prompt that actually lets the agent know what they're building and implementing. All right, it's saying planning next moves. I assume this is going to take a while because I gave the agent a lot to do. So I'll come back with the results of our phase 1 for building out the crypto balance retrieval service. This provider adapter architecture is a really important part of the plan. I want to make sure that Cursor directly knows how this flow is going to go. So essentially it has our flow as classifying the input. So is this a transaction hash, or is this a crypto address and Ethereum network address, or is it a Bitcoin network address? And then we have an orchestrator, and then here we have our 2 adapters, and that's going to be the deciding factor in what balance gets returned. And then also a very important part of this plan, all of the files that are going to be changed, you want to make sure that any files that you don't want to be changed are not part of this list. And then for this .env file down here, it says .env.example, but I think the agent is looking for the API keys from Alchemy. So we'll have to go into Alchemy, generate a new API keys, and then update our .env file so that our application can send requests to Alchemy. This is the dashboard that you will see when you create an account in Alchemy. You can use a endpoint URL, and then they have a curl request that you can use to actually build with. We're just going to put our API key up here in our .env file so that our agent and Cursor has full access to our Alchemy dashboard and endpoint URLs. And so one thing to note when inputting this information into your .env file, your API key over to the right, I'm not going to show you because I need to keep this secure, is not going to change depending on the network, but the endpoint URL will. So you'll need to put in the endpoint URL for each network that you want to use in your application. So as you can see, Ethereum mainnet has this endpoint URL for Alchemy, and if we go to Bitcoin mainnet, the endpoint URL will change. All right, so we updated the .env file with the API key from Alchemy, as well as the endpoint URLs for Bitcoin mainnet, Ethereum mainnet, and Ethereum Sepolia. So that should cover all of the available tokens that we can use on our application, which is Bitcoin, Ethereum, and PaxG. PaxG is the stablecoin for gold, and it's a ERC20 token. So it is compatible with the EVM network. And so right now our agent is moving through the plan and completing the tasks that it generated from our phase 1 plan. This has taken a while. It's been about 5 or 10 minutes, but we want to give our agent a lot of time to build out so that we get a really good result. All right, so it looks like our agent is finally done building. It took a good 20 minutes to build everything out, even though I split up the prompt into two phases, but we wanted to make sure that the agent doesn't cut any corners in terms of building. And so both migrations were updated in Superbase via apply migration. The user address balances was updated with the on-chain column and then also with the lookup metadata. And I'm looking at Superbase right now, and I can see those columns have been updated in Superbase. And so if we come over to Superbase, we can actually see in our user address balances table that the agent has updated on-train snapshots, when these snapshots retired, the input kind, and a host of other columns that are related to our users posting a crypto address and retrieving the balance for said crypto address. This snapshot expires at column is especially important because the users will be constantly refreshing the balance that they're retrieving. And if the balance is stale, then we want to make sure that we have a column to show that this balance is stale. And when the application refreshes, we're going to get a new on-chain snapshot that has a new expiration time. So now that our agent says everything is good to go and we've confirmed in Superbase that our columns are updated, we're going to take some crypto addresses and we're going to paste them into the application. And we're going to see if we can get a balance back from that crypto address, and then that balance can be stored in our database. And then we want to make sure that we can store multiple balances and multiple addresses per user. And so I'm going to do all of that testing. Remember, if you have any questions regarding what we talked about in this video or questions about Web3 or Bitcoin or AI in general, post in the comment section below. This has been session 7 of building a decentralized application. I hope you all enjoyed, and I'm out. Bye, everyone.